The first part of this video is going to demonstrate how to name compounds that contain polyatomic ions. A polyatomic ion is a covalently bonded set of atoms that has an overall negative or positive charge. Examining the chart that is shown on the screen in front of you, there are a wide range of polyatomic ions that can have different charges. Some of the ones that you have to memorize in 9th grade will include the hydroxide polyatomic, that's an OH with a -1 charge, the ammonium ion, which is NH4 with a +1 charge. That will be the only polyatomic that we will memorize in 9th grade with a plus charge, and that's going to act just like a metal does in your type 1 and type 2 naming schemes. Another one that I'm going to ask you guys to memorize is the sulfate polyatomic SO4, which has a 2- charge, and then finally the phosphate ion, which is PO4 with a 3- charge. Now you'll see that there are other polyatomic ions listed on this chart, and on the challenge list that's given to you in class, if you choose to do them, there's about 8 more that you need to memorize. Essentially, what you're going to learn how to do with these 4 polyatomic ions, you can transfer those skills to any compound that contains polyatomic ions. When we name these compounds, there's basically 2 forms, a type 1 compound and a type 2 compound. And just like in binary compounds, when we're naming type 1, all we're going to do is state the name of the metal that is combining with the polyatomic ion that's negative. Ammonium can also be treated as a type 1 compound because ammonium will always form a +1 charge, so you can kind of think of it in the same way. A type 2 compound, just like we've talked about before, is going to be a compound that will have a metal that forms multiple ions, like copper or iron, lead, tin, for example. All right, we'll begin our discussion of type 1 compounds by using a very common ion, calcium. So calcium comes in with a 2+ charge, and we're going to match that up with hydroxide. Now, when I write out hydroxide's formula, I'm going to write OH in parentheses and put the -1 charge on the outside of the parentheses. The reason I'm doing that is to demonstrate the fact that hydroxide is its own unit, that we're not talking about individual oxygen or hydrogen atoms, but we're talking about this OH, which is sharing electrons between the hydrogen and the oxygen. All right, when I go to balance that out, I have a +2 charge on the calcium and a -1 on the hydroxide, which means that it's going to take 2 hydroxides, 2 negative charges to balance out a single calcium. How we write that formula then is as follows: Ca parenthesis OH parenthesis 2. It's very important that that 2 is maintained on the outside of the bracket. What that's telling us is that we have 2 hydrogens and 2 oxygens, which would be the same as if we had looked at it this way. If we had said that there's 1 calcium and we needed 2 hydroxide groups to balance out that calcium, we would have had a total of 2 hydrogens and 2 oxygens, which is what we are seeing over there with the CaOH2. I'm just going to get rid of that for a second. All right, now we need to name it, because that's kind of one of the other purposes of this, is to show how to name things. Again, it's type 1, so when we're naming, we're just going to write down the name of the metal, so calcium. And we're going to then just write down the name of the polyatomic. In this case, we have hydroxide. So CaOH2 is calcium hydroxide. All right, let's do another example. Let's use magnesium, which has the same charge as calcium, so Mg with a 2+, and this time let's put it with the sulfate polyatomic. So SO4 has an overall charge of 2-. Well, this one's kind of fun because if we look at it, the magnesium has a 2+ and the sulfate has a 2-, and those are going to cancel each other out. We only need 1 magnesium for every 1 sulfate. So when we write this, we're going to write Mg, and we're going to drop the parentheses around the sulfate. So we're going to have SO4, and that's our polyatomic compound. All right, what's the name of this? It will be magnesium sulfate. All right, we'll do one more example. All right, the last type 1 example we're going to work with, let's pull an alkali metal. Let's work with potassium. So K has a positive charge. And then we're going to work with that last polyatomic ion, phosphate, PO4. Again, we're going to just put those in parentheses for now, and it has an overall charge of 3-. Okay, when we're balancing this out, it should take how many potassiums to balance out one phosphate? Well, right now we only have a plus charge for one potassium, and we have a 3- for one phosphate. So that must mean that we're going to have to add 3 more potassiums in order to balance out that phosphate. So our answer should be K3PO4. Notice that I've dropped the parentheses around the PO4 because it's really not necessary. Again, when naming this, we're going to name the metal potassium, followed by the name of the polyatomic, which is phosphate. So potassium phosphate is our answer. All right, let's take a look at those type 2 compounds. These ones tend to get a little bit trickier, and sometimes we have a little bit more difficulty with type 2 compounds in comparison. Again, as we talked about with binary compounds, the only difference between a type 1 and a type 2 compound is that a type 2 compound is formed when a metal has multiple charges, and typically those are going to be your transition metals, and there were several other metals that would do that as well. So a classic example of that is the metal copper, and it has a +2 charge or a +1 variation. We'll work with both of those right now. So again, let's put copper with a +2 charge with a hydroxide polyatomic, so OH, again with a 1- charge. In examining this, we can see that it's going to require 2 hydroxides to balance out the +2 charge of copper. So writing that out, we should write out CuOH2. When we're naming that, we're going to write down the name of the ion, so copper. We have to tell which version of copper we're working with. We're working with the one that has a +2 charge, so copper 2. And then we just write out hydroxide, just like we did before. Well, what if we were working with copper 1 instead of copper 2? So if we were working with copper that has a plus charge, and again we're working with that hydroxide polyatomic, it has a 1- charge, we can pretty easily see that the copper is going to balance out the hydroxide in a 1-to-1 ratio. So our answer would be COOH. Again, dropping those parentheses, they're no longer needed. When we name this, we again say copper. We indicate the charge with the Roman numeral, so we have a +1. We're going to write the Roman numeral 1. And then we just name the polyatomic hydroxide. It's a pretty silly Y that I just drew there. Sorry about that. That's the basic of naming the type 2 compounds and writing out their general formulas. What about compounds now that contain ammonium instead of a metal ion? So again, ammonium is NH4 with a plus charge. And we can combine ammonium with any anion. So let's start off with something simple. Let's use chloride. So Cl-. Upon close examination, you can see that it would take 1 ammonium to balance out 1 chlorine. And the ratio is 1-to-1, so our formula would be NH4Cl. Just like before, we can drop the parentheses because they are no longer necessary. As in naming type 1, we would say the name of the cation. In this case, it is ammonium. And then we talk about the anion, and we just change the ending to IDE. So this is ammonium chloride. So chlorine goes to chloride. So that one, again, we start off with a fairly simple example. Let's look at one where there's going to be a subscript outside of ammonium. If we combine ammonium, again NH4, with a plus charge, with oxygen, O comes in with a 2- charge, it's going to require 2 ammoniums now to balance out 1 oxygen. The formula for that should be parenthesis NH4, parenthesis 2. That indicates that we have 2 ammoniums to balance out 1 oxygen. The name of that, simply enough, is ammonium oxide. All right, let's do an example now where we actually add ammonium to a polyatomic. So we're going to do 2 polyatomics together. Slide that up and out of the way. All right, so we're going to take NH4 and let's put it with hydroxide. So NH4, and we're going to put hydroxide in here, OH, with a 1 minus. So a 1 plus and a 1 minus. Well, it's pretty obvious that that is a 1-to-1 ratio. So NH4, OH. One question students ask all the time, since hydrogen is appearing 2 times in this compound, should you just combine them? And the answer is no. Remember again that this is ammonium and hydroxide, and they are 2 separate things. So when we're naming this, again, we're just going to say the name of the first polyatomic, ammonium, and then the name of the second polyatomic, which is hydroxide. So ammonium hydroxide. Okay, let's do one more. Ammonium with phosphate, NH4. Again, positive charge, putting it with phosphate, PO4, with a -3 charge. It's now going to take 3 ammoniums to balance out 1 phosphate. And our charge will be, our compound formula will be parenthesis NH4, parenthesis 3. And will we need the parentheses around PO4? Well, there's only one of them based on what we said earlier. So no, the PO4 will not need parentheses. PO4. What's the name of this? Correct. It's ammonium phosphate. All right, here is an opportunity to practice writing the compound formulas from the names. This is oftentimes an easier skill than naming the compounds themselves. So in this part of the video, I'm going to ask you to pause the video and answer questions 1 through 4 and questions 9 through 12. When you're ready, hit continue and you'll see the answers for those questions. Here is another opportunity to practice. On the left-hand side, all of the compounds are named using a type 1 naming system. On the right-hand side, all of those should be named using a type 2 naming system based on the fact that each one of those metals can form multiple charges. In those, you're going to have to calculate first what the charge of each ion is and then name them appropriately. So pause the video now, try practice problems 1 through 4 and 9 through 12. And in a minute, check your answers. All right, here are your answers. The ones on the left were hopefully fairly straightforward. You're just saying the name of the metal and then the name of the polyatomic. So NaOH is sodium hydroxide. AlPO4 is aluminum phosphate. The hardest part in that is just recognizing the polyatomic when it exists. That's where the memorization comes in. On the right-hand side, you first had to understand which version of each one of those metals was being used. So I'm going to zoom in here just to, again, one more time illustrate that. Cobalt to hydroxide. Well, we had to figure out that the charge of cobalt was a +2. To do that, look at the charge of hydroxide. Hydroxide is going to be a -1 charge. There's 2 of them, which means that the total charge contributed by hydroxide is going to be a -2. Well, if we look at cobalt, there's only 1 of them. So in order to balance out the -2, it must have been a +2. Well, guess where that came from? Our little shortcut here shows us what the charge would have been. Iron 3 sulfate. We know that the charge of sulfate is a 2. That came from this subscript here, right? We're just doing things backwards. So the iron must have had a +3 charge, which is why we have the 3 on the side of the sulfate. The next one, gold 1 sulfate. Again, sulfate has a 2- charge. And there are 2 golds, so to balance it out, we need to have a positive 2. Each gold must have brought in a +1. And in the last one, manganese 4 hydroxide. This one's kind of simple. Hydroxide has a 1- charge, and there's 4 of them, for a total of 4-. We only have 1 manganese, and in order to balance this out so the entire compound is 0, manganese must have had a positive 4 charge. Since there's only 1 of them, all of that came from the manganese. This 4 is the charge of the ion. And those are the shortcuts to figuring out the charges. Hopefully that was helpful and allowed you to get a little bit extra practice. I'm not going to go ahead and give the rest of the answers for 5 through 8 and 13 through 16 to give you guys some opportunity to practice without my help.